Section 8.2 notes, graphs of the other trigonometric functions. This is page 9. And so what we want to do now is graph variations on secant and cosecant functions. And all that means is we are going to graph them with translations. Okay, so again, we're going to take a look at these, and I'm going to graph in terms of their reciprocal functions, and then graph the secant and cosecant from there. So on A, we've got y equals 4 secant pi over 3x minus pi over 2 plus 1. And so let's start with the basics. The amplitude is the absolute value of 4, which is 4. We have a period of 2 pi over 3. Just a little reminder here, that's 2 pi divided by pi over 3. So 2 pi times 3 over pi, and we get a period of 6. Okay. We have a phase shift of pi over 2 over pi over 3. Pi over 2 times 3 over pi. So everything is moving 3/2 to the right. Notice that in the equation it's minus pi over 2, so that makes C a positive pi over 2. So we have a phase shift of 3 pi over 2. We have a vertical shift of 1. And so I'm going to start with that piece right there, and I'm going to move my vertical shift right here to where my 1's going to be. I guess I should number my number line. Let's see, 1, 2, 4, 6. There's my 0. Actually, you know what I'm going to do? Erase that. I'm going to, because of the way this is set up and the phase shift, I'm going to go ahead and make this my y-axis over here. Still going to count the same. -2, -4, -6. It's my 0. And then here I'm going to count 1, 2. I think that's going to work better. Actually, I know it is because I've already graphed it. Okay, so we know that if we did not transform this at all, our 0, my x would be 4 above that shift. So up here at 5. Okay, the whole thing is getting shifted 3 pi over 2. So that's going to be my starting point. Okay, so I'm going to go back to what we talked about when we were graphing sine and cosine, and that's those important points. I'm going to take my period and divide it into 4 equal parts. So my original function, I'd have 0, 3/2, 3, 9/2, and 6. I'm going to go ahead and add 3/2 because that's our phase shift. And so I'm looking at 3/2, 3, 9/2, 6, and 15/2. So at 3/2, that's the start of my cosine function. I am 4 above my midline. At 3, I'm back on that midline. At 9/2 or 4.5, right here I am going to be 4 below the midline, so I'm down here at -3. At 6, I'm back on that midline. And at 7.5 right here, I'm back up at 5. And so here is what that 1 period of my cosine looks like. And because I know this is periodic and repeats, I could even extend this over here. And I know at 0, I'm going to be back on the midline. So wherever my cosine is 0 or hits the midline, I'm going to have an asymptote. So now I'm going to throw those in here. So there's one asymptote. Here's an asymptote. Okay. I know then my cosecant. Let's change. It's going to go from the max of my secant is going to go from the max of my cosine and up towards the asymptotes. And from the minimum down towards the asymptotes. Perfectly okay to leave that cosine function in there as a reference. Make it pretty obvious that you understand that we are using that as the reference. That is not part of the graph. Okay. So y equals 2 cosecant 2x. Here we're not worried about a phase shift or a vertical shift. I figured we'd do the easy one second. So cosecant, just the reminder, that's 1 over sine. We're going to start the same way. Our amplitude is 2. We have a period of 2 pi over my b is 2, so my period is pi. We have no phase shift and no vertical shift, so I'm not going to worry as much about those important points because I can orient this on the 0. So I got 0 here, 1, 2, what's our amplitude? 2, yeah, 1, 2. -3, and how about, let's see, we go, make this pi over 2, and pi, that'll be 3 pi over 2. Okay, now I'm going to go ahead and just graph my sine function. Sine starts at 0, 0. I know that at pi over 4 is my max. Pi over 2 is my max. Did I just say pi over 4? So we got up here. Sorry, pi over 4 is my max because our period is pi. So cramming all these in here. So I know between 0 and 1 pi, I want the sine curve to happen one full time. So I know I got a 0 at pi over 2. That's my middle. I'm going to hit a max at pi over 4 and a minimum at 3 pi over 4. And then, we can take this on the other side as well. And so here's our sine function, happening twice as fast. And so all crammed in there. Okay. So we know we are going to have asymptotes wherever our sine is 0. So I'm going to go ahead and add those in again. Right here at pi and, negative pi, negative 3 pi over 2, negative pi over 2, So because the period is pi, we've got an asymptote every pi over 2. And so let's make sure we're being obvious with our cosecant. Cosecant is the reciprocal of sine, so we're coming from the maximums on the sine, heading up towards those asymptotes, or from the minimum down towards the asymptotes on both sides. Again, the period for our cosecant is 1 pi. Okay, and that's taken us from negative pi over 2 to positive pi over 2. 1 full pi, everything repeats.